One of the most important exponential functions is y equals e to the x. We want to find an inverse for y equals e to the x using the same method I had used in my previous video. Start with the original function. Now we'll want to switch the variables. And at this point, we'll take a log of both sides. Now we get to decide what base we want to use with this log. If no base is specified, then it's assumed that the base is 10. But we would rather have a different base. The best base to choose here is actually e. And it's such an important log in mathematics that it has a special name. ln. ln is called the natural log. And it is simply nothing more than the log with a base of e. Now, we could go ahead and take that y and bring it down in front, giving us ln x equals y ln e. And we're pretty much done with our problem. The last thing to do is to figure out what is ln of e, the natural log of e. You can try to plug it into your calculator. Just press the ln button, and then press the e button. You may have to put in an exponent for e of 1 if you're using the TI-30X2S. And you'll see that ln e is actually 1. That's because ln is a log with a base of e. And so the question would be, e to the what is e? The answer to that, of course, is 1. What I mean is, if we're trying to evaluate ln of e, that is the same as log base e of e. And so in words, this becomes e to the what is e? The answer to this question is 1. E to the 1 is e. So what that means is that ln e is simply 1. They're inverses of each other. So that means that this is gone, and our final answer is y equals ln x. That is the inverse to e to the x. Now we can sketch e to the x just approximately here. E to the 0 would be 1. e to the 1 is e itself. E to the negative 1 is 1 over e. And it's basically going to be a curve that looks something like this. That is the original function, e to the x. Now we want to reflect that function across the y equals x line because, as I discussed in the past, that is a way to find an inverse function graphically. So we have to reflect it, make a perpendicular with the y equals x line, and then just double that size, and you end up over here. We're actually just switching the x and y coordinates. Do the same thing for this point, switch the x and y, and the same thing for that point. Now we can sketch our inverse function. This is the function f inverse of x, which is ln x, the natural log function. For the next one, show that there is no inverse to the function y equals 1 to the x. Well, 1 to the x is actually a really easy function to draw. 1 to any power is itself. So this is the function y equals 1 to the x. Now graphically, I can show that there's no inverse to this function. How do I do it? I have to reflect the points. This point's actually on the mirror line itself, so it won't move. But this point with the coordinates 2, 1, that needs to reflect to a point 1, 2. And then the point 3, 1 needs to go to 1, 3. But you can see what's going to happen here, right? The reflection makes a vertical line. But that is not a function. The dog's barking because that's not a function. Exactly. So there's no inverse. Could we try that algebraically as well? Well, let's see. Start with the original. Y equals 1 to the x. Switch the variables. X equals 1 to the y. Solve for y if possible. Well, let's take a log of both sides. We can bring the y down. And what is log of 1? Well, there's no base there right now, so the base can be assumed to be a 10. And this would say 10 to the what is 1, right? The answer to that is 0. If I were to divide by 0, I would have y equals log 10x over 0. Division by 0. Can't do it. What else would it be? Well, let's say we take the y out of it because we multiply and make it 0. Log 10x equals 0. So 10 to the 0 is x. X can only be 1. And y can be any number. There's no restriction on y. It's not even in the equation anymore. So that's a problem. It's not a function.